The fridge is running throughout the day. When you touch the sides of the fridges, you can feel there is a heat will be there. How it's happening? Why? Where the heat is coming from? Anybody can tell me answer for this? How the heating is coming from? Where is heating coming from?
Sir, once more, sir.
If you test, suppose you are eating the gadgets for a long time, you are getting using cell phone for a long time, cell phone is getting heated. If you are running a fan for a long time, when you touch the fan, the motor of the fan outside the fan will be, when you touch it will be having a lot of heat. When you touch the sides of the fridges, you can feel the heat. Or touch the AC machines, you can feel the heat outside. How we are getting this? From where we are getting this heat? How and where you are getting this heat? Are you applying heat to any one this by you? You apply any heat to these appliances?
Sir, from electricity, sir. The usage of electricity by gadgets makes it heat, sir.
How? Why? What is the reason for this? So you're using the electricity because electricity you are getting heat. So what may be the reason for this?
Electricity.
Now,
See, electricity of two terminals gets heated, sir.
it's okay. That is okay. Why they are getting heat? How they are getting heat?
Sir, with the use of working.
With the working, how their work will be going on? How you are doing your work? How you are walking? How you are walking? What you need for walking?
Sir, energy.
Energy. Yes, electricity is also a form of energy. Already read that, no? While that electricity is passing through the conductor, there will be a wastage of energy. That wastage of energy is dissipates. Dissipates means பிரிஞ்சு போறது. Dissipates in the form of heat. And this is called the heating effect of the electric current. This heating effect is used in the iron boxes, heaters, like so on. What are the ovens like that? Are using this phenomenon only. Are using for the heating purposes. Okay, so from this we can learn that when the current is passing through the conductor, two forms of energy are dissipated there. One is heat energy and another one is magnetic energy. So in the case of magnetic energy, we had read in the last chapter itself. Last chapter on magnetic energy below. So in this part, this is small part only, not a big part. This is small part only. In this part of the last part of this chapter, that is in the we are going to see about the heating effects of the electric current. Heating about the electric currents. So now we can. I will share a small video. You can see that video. This video is given to you from the Practically app. Just wait, I will forget to share the screen. Sorry. I'm able to see my screen. Mathematics, physics, chemistry, biology. உங்களுக்கு தெரியுதா?
Yes, sir.
Yes, sir.
On this first video, I am going to show you now. Able to see the video now?
Heating effect of.
Able to see the video of you?
Yes, sir.
Yes, sir.
Audio is audible?
Yes, sir.
Yes, sir.
Yes.
Electric current. Battery provides energy in a circuit. It is a source of electrical energy. The chemical reaction, taking place inside the cell, results in the formation of potential difference between its two terminals, giving out energy. The motion of electrons occurs as a result of this potential difference, causing the flow of current through the circuit. In certain conditions, the current is produced by only some amount of the source energy, while the rest produces heat. This heat leads to an increase in the temperature of the appliance that is being used. Example: electric bulb becomes warm if used continuously for a longer time. Heating effect of the electric current is generally seen in purely resistive circuits. This effect may be observed when source energy is used entirely to produce heat. Example: electric heater. Consider a current I flowing through a resistor of resistance R. Let V be the potential difference across the circuit. T be the time during which a charge Q flows across the circuit. The work done to move the charge Q through a potential difference V is given as W is equal to VQ. Hence, energy equal to VQ should be supplied in time t. The power input to the circuit by the source is given as P is equal to V into Q by T, which is equal to VI. Energy supplied to the circuit by the source in time t is equal to P into T, which is equal to VIT. The energy expended is released as heat in the resistor. For a steady current I, the amount of heat released in time t is given as H is equal to VIT. By applying Ohm's law, we get H is equal to I square RT. This is known as Joule's law of heating. Joule's law of heating states that the heat produced in a resistor is directly proportional to the square of current for a given resistance, directly proportional to resistance for a given current, and directly proportional to the time for which the current flows through the resistor. Example: an electric heater consumes energy at a rate of 820 watts when heating is at the maximum rate, and 340 watts when the heating is at minimum. The voltage is 220 volts. Calculate the current and resistance. Solution: power input P is equal to VI. Current I is equal to P by V. When heating at maximum rate, I is equal to 820 watts by 220 volts, which is equal 3.72 amperes. Resistance of the electric heater is R is equal to V by I, which is equal to 220 volts by 3.72 amperes, which is equal to 59.13 ohms. When heating is at the minimum rate, I is equal to 340 watts by 220 volts, which is equal to 154 amperes. Resistance of the electric iron is R is equal to V by I, which is equal to 220 volts by 154 amperes, which is equal to 142.85 ohms. Practical applications of heating effect of electric current. Heat generation in a conductor is due to electric current. In electrical circuits, the components get heated up. This increase in temperature may alter their properties. The heating effect of electric current is used in electrical appliances, such as electric laundry iron, electric toaster, electric oven, electric kettle, and electric heater.
So has you seen the video of you?
Yes, sir.
You can go for another video. It's also about heating up and only. Actually, video change. Able to hear audio, so tell me, I'll change the audio. It is not downloading, it is something. So this you got any idea about this heating up electric current now? Don't go to the formula under. Just what do you know about heating up electric current, you know? Okay. Just you can go through the book, means once you can understand what is this.